So I want to kick off with what the definition of domain and range are. Now, I should say domain and range apply to relations, but we're mostly going to use them in the context of functions because we're not going to do a whole lot of stuff with relations that aren't functions. So I'm going to be saying things like domain of a function, or range of a function. I really mean domain of a relation, range of a relation, but I might say it wrong a few times. Sorry, I'll try to get it right. But the basic idea is that the domain is a set of points, and is a set of inputs, and it's the set of all the inputs that you can put into your function, all the legal inputs. Now, in the last video I showed you, or last topic video, I mentioned that you can't put in inputs that would cause you to get a nonsense output. So for instance, let's do an example, right? So I'm going to use functions because I think that's just going to be easier. So here's my function, f of x equals, let's say, 3x minus 2. All right, simple function. So the two main problems that you can have with putting things into your function is you could end up trying to take the square root of a negative number, or you could end up trying to divide by 0. Now you might notice that in this function, there is no square roots and there is no division. So we're not going to have any problems. And the domain here is going to be everything. So I'm going to show you what that looks like on a graph. So f of x equals 3x plus 2, or 3x minus 2. I can put in anything I want. I can put in a negative number, a positive number. I could put in 0. Literally anything I put in will give me some reasonable thing out, right? So 1, I would get 1. F of 2 is going to give me 4. F of 0 would give me negative 2. F of negative 10, right? That's a thing I could put in, would give me negative 32, et cetera, et cetera, et cetera, right? I can put in literally any number I want to. And the way that looks on a graph is like this. So 3x minus 2, it's a line, right? Slope of 3, y-intercept of negative 2. So something like this, right? I'm not going to be super precise here, but we can see that it goes left and right as far as the eye can see, right? It'll keep going left and right forever, and there's no breaks in it anywhere. So this is your basic simple function where the domain is everything, because I can put in everything. Domain, there's a bunch of ways you can write that. All real numbers. I'll say all real numbers. You could put in complex numbers too, like there's nothing preventing that. But I'm just saying real numbers because the only thing on the Cartesian plane are real numbers. You might also say that this way, R with an extra vertical bar. This font right here is called Blackboard Bold, I believe, where you just put an extra vertical bar on the R. There are other letters in this. You can do the same thing with C or Q. Right, those are also common ones that you'll see if you go a little farther in math. But for right now, we're just going to worry about R. So you can write all real numbers if you want. You could write this. You can write it in interval notation. And interval notation looks like this: minus infinity up to infinity. I didn't leave myself much room there. Right, meaning I can go all the way left and I can go all the way right, and everything in there is in the domain. So any of those is totally fine. I don't particularly care which one you do. Just get the idea across of anything is a legitimate input. That's what these things mean here. That all inputs are legitimate into this function because there's no problems. All right, let's look where we get some problems. All right, let's do this real simple function that we probably know. F of x equals 1 over x. Right. So now I can put in almost anything I want there, but not quite. Right. I can't. There's a few things that I can't put in. A few things. There's literally one number I can't put in, but let's look at what it is. So remember that there's, I said there's two major problems: negatives under a square root or divide by 0. Pretty clearly, it's going to be divide by 0 is the problem here, right? You know what? Actually, let me change this function a little bit. I'm going to make it this one over x minus 1. I just want to sort of show you how you go about finding the domain of this. So the way I'm thinking of domain is not so much what can I put in, but what can't I put in? Like which things are no good. And then we're going to start with everything and then just chop out the stuff that's not good, or the stuff we can't put in, right? So my domain here isn't all real numbers. I can't divide by 0, so I can't put 1 in the bottom, right? I need this to be true. I need x minus 1 to not be 0. Now, I think I've mentioned before, but this is a kind of inequality, right? It's sort of the most unequal kind of inequality, right? There's a this is pretty clearly saying that x minus 1 is not 0 as opposed to is 0. You can treat this the same way as you treat an equal sign, right? It does the same, you can do the same operations. Like if I add 1 to both sides, that's totally fine because this is an inequality and you can do with it what you would do with other inequalities. So I'm going to add 1 to both sides of this and get, say, x cannot equal 1. That is the only problem here. Remember, there's only 2 major problems that we have. We could be dividing by 0, or we could be putting a negative under a square root. Well, clearly there's no square root. Divide by 0 is the only problem. And so as long as my bottom is not 0, we're okay. So that means I can put in anything that's not 1. So the way I would want to say that, so let's draw that real quick on a number line, right? 0, 1, 2, 3, 4, 2, negative 3, negative 4. So I can't put in 1, but I could put in anything else, right? So I want to express that as a in a compact way, so that I don't have to draw a picture of the domain, right? I want to be able to say that in some nice way. And the ways are, more or less nice depending on how you want to do this. But basically, what we've got here is I want everything except 1. So I could say all real numbers except 1. Except 1. That's one legitimate way to do it. You could do this in interval notation. Remember, we learned how to link up 2 sets of things to be or 2 intervals to constitute 1 set. And so my intervals would go from minus infinity, like way down here, minus infinity up to 1, not include 1, and then also 1 up to infinity, again, not including 1. So you'd have something that looked like this, minus infinity up to 1, not including 1, and then union that guy with 1 up to infinity, right? So notice that everything in here is included except for 1. 1's not in this interval and it's not in that interval. So it's the only thing that's not in either one. This is a fine way to do it as well. Are there other ways to do this? No, it's just words. Basically, you could say the domain is all real numbers except for 1. Totally fine. That means exactly the same thing as this stuff. What you're going to see, there's another way that people do it. I don't love it when my students do this because I know you don't know the sort of the meaning of this notation, but they'll say things like this. Or I guess they probably don't use the set notation, but our mod 1, or mod the set containing 1. I would prefer if you not do this. And the reason I would prefer that is that this is using notation that doesn't have any meaning for you guys. This mod notation here means something significantly more advanced when you get to group theory, which is like a senior level math class. So it's not, this is wrong, this is correct. But I would prefer if you said something like this instead, because this doesn't just mean except, it means something else. And what we really mean with the domain here would be except. So I would prefer if you use the word, if you do this, I'm not going to mark you wrong. Just be aware that this means something a little more advanced than what we're using it for. So I would pre-write this or this. This is still correct. All right, so let's look at the other problem case where you get something like this. G of x equals, let's say, the square root of 2x plus 4. Okay, so now I mentioned that we cannot have a negative under a square root. So basically, I need this stuff here, the bit that's under the root, not the root itself, but the bit that's under the square root to be at least 0, right? I can take the square root of 0. Square root of 0 is 0. What I can't do is take the square root of a negative number, because then I get complex numbers, which aren't inherently bad, but it's just we're not doing those. So what I've got really is I need 2x plus 4 to be at least 0. And then we solve this inequality, right? Subtract 4, 2x is greater than or equal to negative 4. So x is greater than or equal to negative 2. Right? So this is my domain. Anything bigger than, anything that's at least as big as negative 2 will cause me to get a non-negative number under my square root. So that's okay. Again, we can write this in a variety of ways. I could write this like this, minus 2 up to infinity. We could say all real numbers greater than or equal to negative 2. Ignore my weird R. I don't care what way you say the domain. What I care about is that you get the idea across. That's the important bit. Okay, so now I want to go back a little bit. Do I have room here? Yeah, I want to go back here and show you what this looks like on a graph. Well, actually, I think I'll just do this on Desmos. Let's do that. Do I have a Desmos up? I don't. Hang on one second while I go do that. I'm going to pause for a second. All right, let's try that again. So let's go look at Desmos. And I'm going to put my functions, and I would f of x is 3x minus 2. 3x minus 2. Right, exactly like we said. Straight line, y-intercept negative 2, slope 3, goes left and right forever, etc. So the domain is everything. The next one I did was 1 over x minus 1. And you might notice that this has a gap, right? And it's very specifically this gap, x equals 1, right? So let's go look at this guy. That's, I think we want to make this maybe 0.5. There. There's a hole here. Oop, that's not what I want to do. Where this function never, come on. This function never gets to x equals 0. There's a gap here. And that's what a hole in the domain means. Right? There's no x values that give us meaningful y values for this function. If I made this like 5. Yeah. Right? So there's no x value of 1 that gives me a meaningful y value here. There's a gap. And that's what a hole in the domain looks like. We're going to talk about the y's in a second. That's the range. But that's what, that's what we mean when we say there's a hole in the domain at 1. And there is, right? If I put in 1, I don't get a meaningful y value. All right. The other one I did was square root of 2x plus 4. Right. So we're going to do the same thing, make this a 5. And we can see that we said that x has to be greater than or equal to negative 2. And lo and behold, to the right of negative 2, where x is greater than or equal to negative 2, you see y values. And to the left, you don't. There's nothing over here, right? So there just isn't anything to the left of negative 2, but there's all the stuff to the right of negative 2. So really, that's what those things look like on a graph, right? When we say this, all of the area between negative infinity and 1, that gave you y values, and all the area from 1 to infinity, that gave you y values, but 1 itself did not, right? There was a hole there, which manifested itself as that line where the function would never cross, or the graph would never cross. Similarly, when I say x is greater than or equal to negative 2, what that looks like is you get points for all the x values that are greater than negative 2, and you don't when it's less. Right? So when I look at this graph, I can see that my domain is all the x's that are greater than negative 2, because that's where all the points are, and not where x is less than negative 2, because that's where the points are not. Okay, that's domain. And the way you find your domain in general is you ask yourself, what can my function be or not be? Right? And in general, I like to start with the idea of I can probably put anything into this, but then I will look at the formula and see what things would cause problems. And the two problems I'm most focused on, and for right now, that's all we're worrying about, are dividing by 0 and taking the square root of a negative number. So I want to make my denominator not equal to 0, and that will be any holes I have in my denominator where it is 0, or holes in my domain or where the denominator is 0. And I can't have any negative numbers under the square root. So what I'm going to do is, if I have a square root, I'm going to say that that stuff is greater than or equal to 0 and solve that inequality. And that'll give me where I can have where I can put in numbers. You could also do this the other way, right? You could do the same thing I did on the last one and think to yourself, well, I'm going to start with everything and just chop out the stuff that's less than 0. Right? I could have done 2x plus 4 is less than 0 and found that I would get x less than -2 would be chopped out, which is the same thing as saying that x is greater than or equal to -2, right? Those are the same thing. All right, that's pretty much what I want to say about domain. It's all the numbers you can put in. It's all the legal inputs. The range is all the possible outputs. So it's not super easy to find the range of a function from its formula. And I'm not going to ask you to do that. Instead, I want you to be able to find the range of a function or relation from its graph. And so the range, like I said, is the set of all possible outputs. And if you remember when we were just looking at these guys, right? If you look at this, all the possible inputs are from -2 and up, right? That's all the x values. All the y values are from 0 and up, right? If I'm just looking at what are the y values of the points that I can see here, well, they go down to 0 and they go up from there. So my range is 0 to infinity. That's really what range is. It's just all the possible outputs. So for instance, when I looked at this function has a range of just about everything. It's only missing y equals 0, right? I can't get up to 0 here, and I can't get down to 0 there, but I can get as close as I want on either side. So the range here is all real numbers except for 0. That's pretty common for functions of this type. Yeah, that's really all domain and range are, or that's really all range is. Range is just all the possible outputs. Let me do another more common function. So let's say I have f of x. I don't remember what letter I'm on here. F of x is, let's say, x squared minus 1. Okay, so I want to think about this for a second. X squared can only get down to 0, right? If I put a negative number in for x, okay, let's look at this. So how do I want to do this? I want to do it like this: x f of x. All right, let's do this: -2, -1, 0, 1, 2. All right, so if I put in -2 here, I'll square that, get 4, and subtract 1 to get 3. Put in -1, square that to get 1, subtract 1 to get 0. Put in 0, get -1. This is 0, this is 3. So if we look at the graph, you can see what's happening here. We're getting something like this, right? Which, if you've graphed parabolas before, it's not any kind of surprise to you. So the way I want to think of it is this bit right here, the x squared can only get as small as 0, and then we subtract 1 from that to get down to -1. So this is the smallest value we can get out, right? That's the smallest y value, is -1. It just goes up from there. So that means my range, so let me just address the domain. So the domain is everything. Is all real numbers. The range is all the y's that are greater than or equal to -1. Or if you prefer, right? So when I'm looking at the range, I'm not looking left and right. I'm only looking up. Like how far down does this go? And then how far up does it go? Right? The lowest it gets is here. then the highest it gets is, well, it just goes up from there, right? It can go as high as we want. So what I'm looking for with range, I'm ignoring the left and right bit. I'm only looking up and down. How low does it get? How high does it get? Similarly, when I was looking at domain here, not of this one, but of this, I was really asking how far left does it go and how far right does it go, right? It goes left only to -2, but right up to infinity. So everything bigger than or equal to -2 is the domain. And similarly, how far down does this go? How far up does it go? Well, it goes down to -1, and then it goes up from there to forever, like as far as we want. So my domain is everything, left and right, but my range only goes down to -1 and then is up. And notice that I'm stating the range not in terms of x, but in terms of y, because that's the outputs. And that's kind of all I wanted to say about domain and range. Maybe I'll do one more example. So here, let me whip something up in Desmos, and we'll talk briefly about that. So I'm going to do this function, or not function, but this relation. Let's say x squared plus y squared over 2 equals 1. All right, so there's my relation. And I want to know what the domain and range are of this. So I'm going to think of the domain in terms of like a box, left and right. I'm going to think of domain and range as like a box, left and right, top and bottom. Left and right for domain, and top and bottom for range. So left and right, this goes left as far as -1. -1 there. And it goes right as far as 1. Oh, it doesn't like that. Okay. So there, right? So there's my box, my bounding box. So my range is all the x's that are between -1 and 1. Everything between -1 and 1, I get outputs, and everything outside of that, I don't. Same thing for the y's. This goes down to, oh, it looks like 1.2 maybe? Did I do that right? 1.4? Oh, I know what this is. 1.414. So this is y equals, yeah, I'm sorry. Maybe I should have done this differently. Let me make this a 4, just so it's a little easier to see, because you guys aren't going to obviously know what that is. 2 and -2, right? This goes up to 2 and down to -2. Right? Those are my boundaries. And so that's what I'm going to think of for my domain and range. I like to think of like this box where I sort of slide a function, or slide a line onto the leftmost and rightmost point that I can for the function, and that defines the domain. And I slide a line onto the topmost and bottommost part of the function that I can, and that defines the range. So this has a domain of x is between -1 and 1, and a range of y is between -2 and 2. So let's go write that. So I have my domain, black please. I can write it a couple of different ways. We said it goes from -1 to 1. I would probably rather say something like this. I like this a little bit better because it's specifying that it's x, right? I'm saying that the x's go between -1 and 1. This is clear enough, and if you like this better, then go ahead. The range was -2 to 2, which is to say that y is between 2 and -2. Right? And so that's the way I like to think of domain and range. Now, I will say this. My box it in method doesn't, there are definitely functions for which that's not very effective. But it provides a nice visual sort of intuition for you. It does a pretty good job, to be honest. Sometimes, like, it doesn't work that well with infinities, but you can see that. So yeah, that's what I really want to think of for domain and range, is it's how far left and right the function goes for domain and any gaps that it's got, and how far up and down it goes for range, including any gaps that it has, like not this guy, but like this one, right? That function had that gap at 1, where we couldn't put any x's, right? So that was oops, I wanted to zoom out here, right? This function had the gap at 1, so it's not just how far left and right, but any any holes in there, you have to mention those too. But that's the basic idea. Domain is everything you can put in. Range is everything you can get out. I will only ask you to find domain algebraically. To find the range algebraically, we have to talk about inverse functions first. I'm not going to worry about that. Finding range algebraically isn't tremendously important anyway, I have to be honest. So yeah, that's really all I want to say about domain and range. So I'm going to go ahead and stop the video now, and I will see you guys in the next one.